More than 2,000 years ago, Greek craftsmen built an extraordinary machine. Hidden inside bronze and wood, tiny gears modeled the heavens. But how did ancient Greeks create such remarkable technology? The answer begins with astronomy.
The moon and sun follow different cycles, challenging ancient calendars. Greek astronomers studied these patterns, discovered repeating relationships, and learned that eclipses followed predictable cycles,
turning mysterious celestial events into measurable science.
The Saros cycle revealed that eclipses could repeat after roughly 18 years. Greek astronomers transformed these patterns into mathematical astronomy. Eventually, an unknown Greek engineer turned those calculations into a remarkable mechanical device. Bronze gears transformed mathematics into mechanical motion. The intricate device was enclosed in a wooden case, covered with astronomical markings. A user could turn its handle, causing the internal gears to calculate celestial cycles. The front displayed the zodiac and celestial cycles. A sun pointer tracked its annual journey through the zodiac.
Ancient astronomers connect mechanical movement with the changing position of the sun across the heavens.
The moon was harder to model because its motion changed speed. Clever gears reproduced this irregular movement, while another system tracked lunar phases, turning complex celestial motion into mechanical prediction.
Inside, interconnected gears represented different astronomical cycles, creating a tiny mechanical universe.
On the back, spiral displays compressed long periods. The upper spiral represented 2 to 35 lunar months across 19 years. The spiral transformed hundreds of lunar months into mechanical movement. Accurate calendars helped organize ancient life and festivals.
Below it, another spiral represented 223 lunar months, forming the Saros eclipse cycle.
The mechanism's eclipse markings revealed possible events. scholars could identify eclipse types and timing. An exeligmos cycle helped correct timing shifts.
To ancient observers, eclipses became predictable mathematical events, not magic.
The mechanism carried detailed Greek inscriptions explaining its astronomical functions. Then its story vanished from history. Eventually, the machine traveled aboard an ancient ship, carrying its secrets across the Mediterranean toward an unknown fate.
Near Antikythera, the ship sank, burying the mechanism beneath the Mediterranean.
For centuries, corrosion consumed its wooden case and bronze gears. Then, in 1900, sponge divers discovered the wreck and ancient cargo. A strange, corroded, bronze lump emerged from the wreck. In 1902, Spiridon Sties noticed a hidden gear. Suddenly, archaeologists faced an astonishing question. How could ancient Greeks build such a machine? For decades, researchers studied the mysterious fragments, measuring gears and inscriptions. Then X-ray technology revealed hidden structures beneath corrosion.
Suddenly, scientists could gears, shafts, and inscriptions buried inside the ancient bronze.
Scientists combined archaeology, astronomy, and engineering to rebuild the machine. They discovered it performed mechanical calculations, representing celestial information through continuous motion, making it an ancient analog computer, long before electronics existed. Its gears revealed remarkable precision, modeling complex astronomical movements. Its calculations also reflected Babylonian knowledge.
Greek engineers transformed mathematical astronomy into physical machinery, encoding celestial cycles directly into bronze gears.
An astronomer could turn the mechanism and watch celestial indicators move. The eclipse dial could signal approaching events. Yet much remains unknown, with missing fragments, damaged inscriptions, and uncertain reconstructions, still challenging researchers.
The mechanism may represent a lost tradition of ancient technology.
Today, it stands as evidence of extraordinary Greek engineering, revealing how mathematics, astronomy, and bronze were combined into one remarkable mechanical computer.